So if all I wanted was the vertical asymptote, my vertical asymptote would be 4. But there's a big caution, big caution. If they're asking you for your domain, you must eliminate or not include anything that makes this function discontinuous. When you graph on the graphing calculator, the pixels are so big you will not see the whole. So even though it is not an asymptote, you do not simplify anything when you're doing domain. So when you're doing domain, you will have to exclude -1 and the 4. But when you're doing vertical asymptotes, we don't include the -1 because it's a whole. Are you with me, Jesse? What, the asymptote or the domain? Domain, I always want an interval notation. Okay? So let's do another one just to make sure you've got this. Suppose I have x plus 2, x minus 3, over x minus 3, x minus 10. What's the domain? -infinity to 3, 3 to 10, and 10 to infinity. Now, what's the vertical asymptote? Jake, what's the vertical asymptote? All right. What is not a vertical asymptote? X equals 3. What is x equals 3? A whole. What's your whole? Whole occurs at x equals 3. Notice the at. X equals 3 would be a line, so we're saying it occurs at the x value of 3. So any questions on that? All right, so today it's important that you take notes. I cannot explain why today because it requires calculus. And because we don't have calculus, you'll have to wait until you take that course to understand why behind of what we're doing. This homework assignment should take you probably all of maybe 5 minutes. You'll find horizontal asymptotes. All right, Joey, are you willing to be the recorder? Is that a yes? Okay. So let's go for our horizontal asymptotes. Vertical asymptotes occur when the denominator equals 0, after wholes are removed. All right, so let's fast forward. There's vertical. All right, so you need our objective to identify the vertical. We did that the other day. Today it's horizontal. And my guess is another day is going to be slant. But today we're going to focus on horizontal of a rational function. Now, I color-coded these to help you. But you're going to have to know these rules. If you don't know these rules, then it's hard because you have no clue. If you had the calculus, then you wouldn't have to memorize the rules. Let n, in red, be the degree of the numerator. Why did I let n be degree of numerator? Why is n representing numerator? Because numerator begins with, yeah. And let d be the degree of the what? Denominator. I have no clue how the book did this, but I think that when you let n be numerator, d be denominator, it's a lot easier to keep track of. Now, a is the leading coefficient of the numerator, and b is the leading coefficient of the, yeah, I couldn't do n and d anymore. So I'll pause while you write. Possibilities. 3 possibilities of the relationship between n and d. N could be bigger, n could be equal, or n could be smaller. Those are the only possibilities. N is bigger. Oh, that is not a highlighter. N is bigger, n is equal to, or n is smaller. And it's all about that. Now, when n is greater than d, then there is no horizontal asymptote. Now, in order to have a slant asymptote, there must be no horizontal asymptote. And n must be only 1 more than d. for the slant asymptote to occur. But that is whatever this word is. Now, if n is equal to d, then there is a horizontal asymptote, and it is in the form of y equals, now do you see where the a over b is coming in? Leading coefficient of the numerator, leading coefficient of the denominator. So this will vary. When n is less than d, the horizontal asymptote will always be y equals 0. So all you have to do is compare the degree of the numerator and the degree of the denominator, and you have your asymptote. And that is all you have to do on 29 through 36. And how many problems is that? Yeah. I assigned you everything the book had. So here we go. You ready? All right. So in the first problem, what is the degree of the numerator, Nicole? I can't either. I can't move it. Okay, hold on. There. Is that better? Okay. The degree of the numerator is 2. I need to know the degree of the denominator, and the degree of the denominator, Shalisa, is 2. So then you're going to look at your little notes, and you're going to say, what is the relationship between those two degrees? Oh, Toby's not here. Angie? They're the same. So when they are the same, what is going to be our horizontal asymptote? Delaney? So it's going to be y equals, what is A? Leading coefficient? 6 over? Leading coefficient of the numerator is the coefficient in front of the highest degree. Leading coefficient of the denominator. There you go. Now what does that reduce to? Right. So your horizontal asymptote is y equals 3/4. Going to the right, what is the degree of the numerator, Abby? What is the degree of the denominator, Matt? This one. Okay, so what is our relationship, Matt? What is my horizontal asymptote? No horizontal asymptote, because the degree of the numerator is larger than the degree of the denominator. When we get to slant, will there be a slant asymptote? Yes, because that's only one more. All right, we're going left corner now. What is, Shalisa, what is the degree of the numerator? What is the degree of the denominator, Nicole? And therefore, what is this asymptote? Chase, horizontal. This is degree 1. This is degree 4. What's its relationship? So what is your horizontal asymptote? Y equals 0. Now make sure when you give me an equation, you got the y equals for horizontals. Verticals are x equals. All right, this one over here. What is the degree of the numerator, Mike? What is the degree of the denominator, Justin? Degree of the denominator? Okay, 3. So what is our horizontal asymptote, Jesse? Y equals 2/3. Any questions? None? Okay, so let's talk about your quiz Thursday. All right, we are going to go into rational functions. All right, and this is the parent graph. One of 2 parent graphs you have to know. Can you guess what your quiz on Thursday is? Being able to what? Graph the which one? Just the parent. That's correct. I need you to be able to graph 1/x in about 30 seconds or less. Because what do you think we're going to do to this? Shift it. Left, right, up, down, fat, skinny. All right. Now, what's special about this?
Wait, will you draw it?
Pardon?
Yeah.
I'm getting there. This is a vertical asymptote. This is a Horizontal asymptote.
Do we have to draw the asymptotes?
So let's explain, why is the vertical asymptote x equals 0? Why is vertical asymptote x equals 0? Where do we get that? You take the denominator and do what? Okay, why is the horizontal asymptote y equals 0? How'd they get that? Degree in the denominator is 1, the degree in the numerator is 0, so yeah, that is correct. So what points do you need to know? You need this one, which is 1 over 1. If you put 2 in here, you get 1/2, correct? What happens when you put a half in the denominator? You get 2, so 1/2, 2. Those 3, and then they're origin symmetry ones. This one is -1, -1. If you put in -2, this point will be -2, -1/2, and if you substitute in a -1/2, what does that do? -2. Those are the points I need to see plotted. How did I get those points? Plugging them over here. They just didn't fall from the sky and hit us in the head. All right, domain. Sterling. Interval notation. Oh, there's a problem. So leftmost is -infinity, no. What's your... No, it goes further. It's closer and closer. What is this in the x? Yep. Never gets past 0, but then it picks up on the other side starting where? At 0. Notice a parenthesis means it doesn't include it, and then where does it go? Right. Okay, so now we're going to go down to range. What is my range? Morgany? -infinity to 0, because we're going down forever, and then we're going to come up, and we won't get past that 0. And then what? 0 to infinity, because we're here, we'll never touch that, but then we're going to go up forever. Actually, we're starting at 0, and we're going to positive infinity. Symmetry. This does have symmetry. What kind of symmetry does it have? Jesse? Is it symmetric with the x-axis? Is it symmetric with the y-axis? So what's the other symmetry? Starts with O. Origin. It's our origin symmetry. That's the rotational one. If you were to rotate this 180 degrees, that would fall on top of that. Also known as odd. So are all of these points exact opposite of all those? That is your odd symmetry. Now remember, we've done increasing, decreasing before as your eye travels left to right. Michael, where is this function increasing? Eye travels left to right. Okay, so if I start here and I trace, is my pin going up? Am I increasing here? If I start from the left and I continue to trace, am I going up? Is this graph increasing? Never. All right, where is this graph decreasing? This goes to Chase. Right. All right, x-intercept. That means where does the graph cross the x-axis? Nicole? Is it going to touch the x-axis? Because of the... So there is none. All right. Jake, are you awake? What is my y-intercept, Angie? Does y equal 0 anywhere?
No, it doesn't.
Because there is an asymptote, exactly. All right, so now you should be able to give me the equations of the vertical and horizontal asymptotes. Vertical asymptote goes to Justin. Which is it?
0.
Okay, because you haven't moved left or right from the y-axis, it is indeed x equals 0. And your horizontal asymptote goes to Joey. What is it?
Horizontal asymptote is y equals 0.
Y equals 0. So those are the properties of your parent graph. We have more. Oh. You ready? Here we go. Your second graph that you have to know, parent graph, is y equals 1 over x squared. This too. Can you handle that for Thursday?
I don't know.
Yes, we can, Mrs. Bride.
I think we might need to bump it to 45 seconds.
I was going to give you a minute
Oh, okay.
for the two of them.
Oh, I thought it was 35. I thought it was 30 seconds total. Okay.
Okay. Ready? We've got 1, 1. Now what happens when you put 2 in? Is it a half anymore? It is what? No? What's 1 over 2 squared? Where? Let me put in the asymptotes. You have an asymptote on the y-axis. You have an asymptote on the x-axis. So when you put 2 down here and square it, what's your number? 1/4. Do you see how it's lower than a half? Now what's going to happen when you put a half in? It's going to become a quarter, and then what will happen? It'll end up to be 1/2, 1, 2, 3, 4. So we've got 1/2, 4. Now what kind of symmetry is this, by the way? Even y-axis. So you've got this ordered pair, which is negative 1, 1. You've got this ordered pair, which is negative 2, 1/4. And you've got this ordered pair up here, which is negative 1/2, 4. Matt?
Will you accept if we should just say even or odd? No, does that have to be origin?
If it asks for symmetry, they want to know y-axis, x-axis, or origin. But it is technically kind of one and the same. All right. I need the domain for this function, Matt. All right. I need a range for this one. The range is going to go to Matt. Why do I have to put a parenthesis on 0? It's not included. All right, I need symmetry. What is my symmetry, Morgan M?
No, it's not.
Symmetric with respect to?
The horizontal. No.
Your hands went in the right direction.
Wait.
What axis are you going to fold it on?
The Y.
There you go, y-axis.
Gotcha.
Okay, increasing, decreasing, increasing first. Where is this graph increasing, Gianna? Left to right. When is your pencil going to go up as you trace? Higher. Further this way. Because it goes that negative. It keeps going. Negative infinity. And it's going up, 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 up to when? No? It's not going to go past that green line. 0. So that's where it's increasing. So now where is it decreasing? Nicole? 0 to infinity. You get on the other side, now all of a sudden I'm coming down. X-intercept goes to Joey?
X-intercepts, S.
Where does it cross the x-axis? Nowhere. Why?
Because
There's a horizontal asymptote. I need to know the y-intercept, Angie.
Y. No, not.
No, I need a y-intercept. Where does the graph cross the y-axis? Is it going to touch? Look at that dotted line. What does that dotted line mean?
not gonna touch.
It's not going to touch. Therefore, there is none. All right. Yes. Because it's getting closer and closer and closer to 0, but notice we didn't put a bracket. Okay, so it's not going to touch it, but it'll get incredibly close. We're not finished. Abby. What, Mrs. Bride? Thank you. Vertical asymptote. What's its equation? Yep, x equals what? Yep. And I need a horizontal asymptote. Delaney. Y equals 0. All right, do you understand what is expected for the quiz Thursday? Do you understand what is expected for your test tomorrow? You need to study. The objectives are online. Yeah. Okay, and then this is where we're going to start. This is where we're headed. This will be Thursday. We're going to transform.